Assalamualaikum and hi again. So this is the first chapter for Foundation in Science and also for Foundation in IT students, which is number system or system number. Okay, let's see what is in this chapter. So the first one will be the first subtopic will be the real number ataupun nombor nyata, real number. So in this subtopic or in real number, you're going to define and understand what is natural, whole, integers, prime numbers, rational, and also irrational numbers. And also, you're going to learn how to represent rational and irrational numbers in decimal form. And then you're going to represent the relationship of number sets in a real numbers, and also to state clearly the properties of real numbers. And you're going to understand about open or closed and half open interval. And we also have the end point of an open interval, or you will have n points of a closed interval. One is n point of open, the other one is closed interval. And last but not least, in this subtopic, you will learn how to simplify union and also intersection of two or more intervals. Okay, so let's see the first one, which is natural numbers. So what is natural numbers? Okay, sorry. Okay, natural numbers is the set of counting numbers. So it is represent as capital of N, counting numbers, meaning that numbers that you can count start from 1, 2, 3, 4, 5, and so on. Okay, and this counting number does not include 0 because 0 you can't count. Okay, it starts with 1. So in natural numbers also you will have prime numbers. So what is prime numbers? The number greater than 1 and can be divided by itself only. Sorry, which means that in prime number, you will start with 2 because the number must be greater than 1 and can be divided by itself only. So you will start with 2, 3, 5, 7, and so on. Why is it no 4 over here? We start from 2, 3, and 4 because 4, we can divide 4 by 2. It is clearly mentioned that prime numbers is the one that can be divided by itself only. Cuma boleh dibahagi menggunakan nombor itu sendiri. But 4 we can divide by 2. So 4 is not a prime number. As well as 6 over here. We miss 6 over here. There is no 6 because 6 can be divided by 3, can be divided by 2, can be divided by 1. Okay. So be careful, prime numbers. Okay, it starts with 2, 3, 5, 7, and so on. Okay, that is about natural numbers and also prime number. Let's see about whole numbers. Okay, do you know what is the whole numbers? Nombor keseluruhan. Okay, so whole numbers mean this one. The natural numbers together with the number 0. Okay, previously natural numbers we only mentioned it start from 1, right? Natural numbers, the one that you can count. But now whole numbers mean it include 0. So it is represented by capital of W, huruf W besar. So W or whole numbers is 0, start from 0, 1, 2, 3, 4, 5, and so on and so forth. Okay, so why does we put a curly bracket over here? Because it is a set of number. Okay, that is whole numbers. Then next is the integers. What is integers? The whole numbers together with the negative of counting numbers form the set of integers and denoted by capital Z. Okay, so it said that integers is the whole numbers. Whole numbers mean we start from 0, right? together with the negative. Okay, so it become larger. Now the set become larger. Previously you only have natural numbers which start from 1. Then you have whole numbers which include 0. And now you have integers which also include negative. So the set become larger. Lagi banyak nombor inside. Okay, so it is denoted by capital Z over here. So it starts from blah blah blah, negative 100 might be negative 1000, negative 3. As long as it is negative, so it is integers. Okay, then 0 also include 1, 2, 3 and up, so on and so forth. That is integers. I hope that you clear about the integers, whole numbers and also natural numbers, and we have the specific one which is prime numbers previously. Okay, let's see the relationship. Okay, integers, we have positive integers or denoted as Z, and then we have positive superscript. Dekat atas dia ada Z plus. Okay, then we have positive integers is 1, 2, 3 and so on and so forth. And then we have 0. And also we have negative integers, Z, and then we have the power negative over here. So this includes negative numbers. Okay, that is about integers. And also we have integers of odd numbers. Odd numbers mean nombor ganjil. So the formula will be 2k plus 1. That is odd numbers, nombor ganjil. Like 1, 3, 5, 9. That one is odd numbers. And then we also have even numbers or nombor genap. The formula is given by 2k. Like 2, 4, 6, 7. 2, 4, 6, 8, 10, so on and so forth. Okay, that's it about integers. Then we move on to the next numbers, the type of numbers, which is the rational numbers. Nombor rational. A rational number is any number that can be represented as a ratio or quotient. Ratio dalam bentuk nisbah of two integers and can be written as, rational numbers is denoted by capital Q. And it can be written as A over B, where A and B is actually Z just now is Z or Z just now is the integer, and B over here cannot be equal to 0. Dia punya penyebut tidak boleh sama dengan kosong. Apa maksud rational numbers? Rational numbers mean any number that can be represented as ratio. Apa-apa nombor yang boleh ditulis dalam bentuk nisbah ataupun quotient mean pecahan. So that one is rational numbers. When you have rational numbers, you will also have irrational numbers, perlawanan lah. Then rational number can be expressed as terminating or repeating decimals. Maksudnya nombor rational juga boleh di express ataupun boleh ditulis dalam bentuk terminating or repeating decimals. We will see what is repeating and terminating decimals. Later on I will show you. And then like I mentioned previously, when you have rational numbers, you will also have irrational numbers. Nombor tidak rational. What does it mean by irrational numbers? Is that the number that cannot be written as a quotient and non-repeating decimal numbers. The main highlight is that cannot be written as quotient. Tidak boleh ditulis dalam bentuk pecahan dan tidak boleh ditulis dalam bentuk nombor perpuluhan yang berulang. Non-repeating. Maksudnya tidak berulang. For example, like this one. We have 0.452138. Is there any repeating numbers at the end? No. There is different number. Tidak ada nombor yang berulang. So this one we call it as irrational numbers. And also cannot be written as a quotient. Tidak boleh ditulis dalam bentuk pecahan. So you will have like this, cert 3, punca kuasa 3 and also pi macam tu. So all these are the irrational number. So let's see the difference of rational numbers and irrational numbers. What does it mean by repeating or terminating decimal numbers? So you have 1 over 3. 1 over 3 is a quotient ataupun boleh ditulis dalam bentuk pecahan. So as long as it can be written in rational or in the quotient dalam bentuk pecahan dan juga nisbah, it is a rational numbers. Okay, so you have 1 over 3, 4 over 11, 1 over 4. That's all is all of fraction or quotient pecahan. And also you see over here at the end, we have the decimals which is repeating 0.3333333 and so on. Okay, the 3 over here will keep repeating until the end. And also over here we have 36, 36, 36, 36 and so on. The 3636 number is keep repeating. So that is what we call as repeating. These two is repeating decimal. So it is concluded as rational numbers. And also we have this one 0.25. This is terminating. Terminating mean terhapus. Dia tidak berulang. Dia terhapus. Dia exactly 0.25. And this is also rational numbers, still rational numbers. But when we have like this, square root of 2 in the form of square root, punca kuasa, or when we key in the calculator, you will have the output 1.414. There is no repeating numbers over here, right? So this is irrational numbers. And also we have pi. Pi, when we key in pi in the calculator, you will have this 3.14159265 and so on and so forth, right? So this is none of the repeating. Tidak ada yang berulang. So this become irrational numbers. So I hope you can differentiate between the rational and also the irrational numbers. Okay. Next, we have numbers that either rational or irrational are called real numbers or denoted as capital R. Okay, both rational and irrational, we can conclude them as real numbers. Dia mix between those two. Kita gabungkan dua-dua rational and irrational. Okay, ataupun salah satu pun kita boleh panggil as real number, either rational or irrational. Okay, so this is the relationship of number sets. Previously we have learned about natural numbers, which is numbers that we can count, start from 1 to 3 and so on. And then we have whole numbers which include 0, 0, 1, 2, 3 and so on. And then we have another one which is z, which is integers. So when you have integers, it included negative numbers. So the set become larger and larger. Lagi besar, set tu semakin berkembang. And also we have Q. Q is irrational and, Q is rational numbers. And we have Q over here, Q complement. Q yang ada bar dekat atas dia, kita panggil Q complement. Maksudnya selain daripada Q yang ini. So Q complement mean those others than this Q. So this is irrational, this is rational. Then the whole thing is, we call it as real numbers. That is real numbers. Okay, so this is the whole picture of the relationship of number set we have learned previously. So from the diagram, we can see that number 1, natural numbers is a subset. This icon over here is symbol over here is subset, ataupun kita panggil anak kepada. N is anak kepada W, W is anak kepada Z. N is a subset to W, W is a subset to Z, Z is subset to Q, and Q is subset of R. Maksudnya semua ni terangkum ke dalam R. R is the biggest set. And then number 2, we have Q, union Q complement. Union mean you mix up, you gabungkan you mix up or you total up these two, this whole thing q and this q, you will have real numbers. This u over here is union. Union means you combine both set q and q complement. Okay, that is about relationship of sets. Okay, next we have for the set of these numbers. In this set we have -5, -3, -1, 0, 3 and 8. Identify the set of natural numbers. So the natural numbers will be natural numbers, the one yang you can count, yang you boleh kira. So it will start from 3 and 8. Okay, only from this set. Okay, you can pick the answer only from this set. Okay, how about whole numbers? Whole numbers mean you have to include 0, 0, 3 and 8. And prime numbers, what does it mean by prime numbers? Just now, it must be greater than 1 and can only be divided by the number itself. So lebih besar daripada 1 dan cuma boleh dibahagi oleh nombor itu sendiri. So you have 3 over here. Because 3 can only be divided by 3. And you get 3 bahagi 3, you get 1. But for number 8, it is not a prime number because 8 can be divided by 2, can be divided by 4. So it is not a prime numbers. Okay. So that is the examples of the number system. And then even numbers, nombor genap. From the previous set, nombor genap we only have 0 and 8. Cuma ada 0 and 8, even numbers. Then negative integers. So the negative integers are denoted as z, and we have small letter of small z power of negative over there. So you just list down the negative numbers. And the odd numbers will be included the negative numbers. -5, -3, -1 and also 3. Okay. That's quite easy, right? And then express each of these number as a quotient. Okay, maksudnya you gonna express dia, tulis mula dalam bentuk quotient, dalam bentuk nisbah atau pecahan. So we have 1.5555. This is repeating number, so we call it as rational numbers, right? So first thing you need to let x equal to 1.555. Okay, this thing you let it as 1.555 x. So we let this as a first equation. So the first equation we will multiply it by 10. So when you multiply this thing by 10, you will get 10x. Darabkan dia dengan 10, 10x. Then this one, when you multiply with 10, you have 15.555, right? Then so this become your second equation. So you have two equations, first one and second one. Thus, we minus the second equation with the first one. So bila kita tolakkan the second equation, tolak 10x minus x, you get 9x. 15.555 minus 1.555, you will get 14. See, the 555, the repeating numbers at the end, you will cancel out, boleh potong. So just tinggal 15 tolak 1, you get 14, 14. Okay, so 9x equal to 14. So x equal to this 9 over here, we bring it on this side, it become 14 over 9. That's it, you get the answer. So this is in term of quotient dalam bentuk pecahan. This is in term of repeating decimal. Nombor perpuluhan berulang. Okay, then let's see the second example. We have 5.45959. Apa yang berulang dekat situ? What is the repeating? The repeating numbers is 5959, right? So let's see how we're going to solve this. First, let x equal to this whole thing. This become your first equation. And then the second equation will be the first one, you multiply it with 10. So the first equation, when you multiply it with 10, you have 10x equal to 54.5959. So then number 3, the third equation will be the second equation, you're going to multiply it with 100. So you will get another equation which is 1000x 5459 then 5959. Therefore, you can just minus the third equation with the second equation. Sorry. So you will get 990x equal to 5405. So now you just this 990 you can just bring it over this side. So you will have this, and then you can simplify this, permudahkan, then you get this one. Okay, so that is how you change from the repeating decimals to the quotient form dalam bentuk pecahan. So let's see some of the properties of real numbers. We have altogether six properties for addition and multiplication, untuk tambah tolak, and also you have multiplication untuk yang darab. So the first property is closure. What does it mean by closure? For example, when you have a number, any number A and B, so A plus B, you will have C, where C is a subset of R, real numbers. Contoh, you have, for example, you have 6 plus 7, you have 13, where 13 is actually a subset of R. Okay. Then for multiplication, you have this kind, A, B equal to, you multiply A and B, you will get D. So for example, you multiply 6 times 7, you get 42. Still, it is a subset of R. Okay, it is element of R. This symbol mean element. Element kepada R ataupun subset kepada R jugalah. Then the second property is commutative. What does it mean by commutative? Commutative ni senang. You can see it. A plus B, it's also similar with B plus A. Means they are interchange position. Dia apa ni? Terbalikkan sahaja dia punya kedudukan. A plus B, and the other side it will be B plus A. Ataupun for multiplication, you have A times B or B times A. The answer is similar. Dia terbalikkan position sahaja, kedudukan yang berubah. But for the third one, you have associative. For associative, we play around with the bracket. Kita bermain dengan bracket. Commutative just now is kedudukan or the position. For the associative, we play around with the bracket. Okay, so let's see. We have bracket A plus B bracket plus C is actually equal to A plus bracket B plus C. So the bracket is dekat mana pun, wherever the bracket will be, the answer is still the same. Okay, sama juga like this one. A, B bracket, and then you multiply with C. It's also similar with this one. A bracket B, C. So the answer is similar. So associative will play with bracket. And then you have the fourth properties will be distributive. Okay, distributive mean you distribute. Distribute mean kita bagi-bagi kan? Kita edar-edarkan dia. So distribute also mean you kembangkan dia, you expand it. So you have A and then you have bracket B plus C. So what happen when you have this bracket and you have A over here? So you're going to open the bracket, means that you're going to multiply this, each of these, A times B plus A times C. So you will get this. So that is distributive. Distributive mean you edarkan or you bagi-bagikan or you kembangkan. Okay, that is distributive. Distribute. And then the fifth properties is identity. So identity mean when you A plus 0 also equal to 0 plus A. Also equal to A. Maksudnya bila you any number you tambahkan dengan 0, you will still get that number also. That one is identity. That one is for addition. For multiplication, you have any number, you multiply it with 1, then you will get that number also. Okay, so apa-apa number you tambah dengan 0, you will get that number balik kan. And then apa-apa number you multiply it with 1, you will get that number back. So maksudnya that one is identity. You dapat nombor tu semula. You get that numbers again. And then the last property will be inverse. Inverse mean terbalik. Terbalik. Okay, songsang. So, for example, if you have A plus negative A. So, this one is positive, this one is negative. So, of course, you will get 0, right? So, sama juga when you have 7 plus negative 7, so you get 0. That one is inverse. For addition, untuk tambah. And then how about multiplication? So, untuk yang multiplication, 1 over A times A. So, you can cancel out this one. A you can cancel out. So, it become 1. So, macam ni juga lah. 1 over 5 times 5. So, you can cancel out the 5. You get 1. That is inverse. Okay, let's see the example. Write down the type of properties for this statement. Okay. Properties for this statement, 3 plus 4x equal to 4x plus 3. So this one is you play around with the position, kedudukan. So this will be commutative. This is the commutative properties. And for B, you can see over here, x, and then bracket y plus z, and then you expand it. So this will become distributive properties. And the C, 3ab plus 0. So 0, anything plus 0, you will get this thing back, right? So this is identity for addition. And this one 2 times 3n. Also equal to 2 times 3 and n at the outside. So bila kita main dengan bracket, this one is associative. Okay. So, I hope that you clear about these 6 properties. Okay, we also have another examples. Okay, let's see. Example, given A and B is an element of R real number. A, B equal to 1. So, prove that A equal to 1 over B. So, solution, dia bagi kamu A and B, yang mana A and B itu adalah real numbers. And also, bila A times dengan B, you get 1. Buktikan A is equal to 1 over B. So, solution, given A equal to B, A times B equal to 1. Okay, let me, A, B, times, so the first thing you need to do is you're going to multiply it with 1 over b, since it's already given over here. Prove that you need to prove this one. So we just take this 1 over b, we multiply it in both sides, darabkan dia di kedua-dua belah. So for now, jangan dulu mansuhkan, jangan dulu potong ya. You don't have to cancel it out first, just let it be macam ni. Okay, now A, you take it at A, so let B sahaja yang dekat dalam, B times 1 over B. So this one, bila you kembangkan, you still have 1 over B. So, bila bermain dengan bracket, we have associative. And identity is for this part. Identity is for this part. Associative is for this part. This part over here. Okay, so now you can cancel it out. B times B. Yang tinggal cuma A times 1. And then this one 1 over B. So this one become inverse. Anything yang you darab semula dengan 1, it is inverse, kan? And then A times 1, you get A itself. So that one is identity. So that's it. You have proof that A equal to 1 over B. Okay. For this question, it just want to you. This question, it want you to actually define the properties for each step. Okay. Then let's see. Next is number line, system number lines. The number line. Garis nombor, not system number, I'm sorry. Garis nombor, okay? What is garis nombor? The number line, the set of numbers that correspond to all points on number line is called the set of real numbers. Okay. So number lines ni dia include all set of real numbers. Real numbers apa tadi yang kita belajar? It include negative, which is integers, zero, and also natural numbers. So the whole things. So that is this is number line ataupun garis nombor. Okay, the real number on the number line are ordered in increasing magnitude from the left to the right. Okay, maksudnya susunan garis nombor tu meningkat dia daripada smaller to the biggest. See, this one is negative and then you keep increasing until the bigger number, positive number. So let's say this is type of interval. Okay, what are the rest? Okay. So type of interval, the first one is open interval. Okay, open interval. So you have this bracket, open bracket, A to B. Or you have in the curly bracket, in the form of set, you will write it down as like this, X titik bertindih, X greater than A, less than B. This one is in set form. So when you have a number line, we draw it in like this, A and B. This is open dot. Okay, you will always use open dot because this is open interval. When you have closed interval, meanings you have to use close bracket. This one, close bracket. This one is open bracket, this is close bracket. And also when you draw the number line, you have this dot. Exactly yang hitam ni, bulat kan. They're shaded, okay? They're shaded. And this one is half close ataupun half open. We can call it half close and half open. Separuh buka, separuh tutup. Okay, let's see the example. List the number, describe and graph the numbers on the number line. The whole number less than 4. Okay, whole number less than 4. So for whole number less than 4 mean 0, 1, 2, and 3. Okay, so you can this one until this. Okay, the integer between 3 and 9. So the integer between 3 and 9, we will start with 4 di antara 3 dan 9. So tidak termasuk 3, okay? So it will start from in between, which means does not include 3 and 9. So we have 4, 5, 6, 7, and 8. So that's it. You just dot kan dia, okay? Okay, and then you have also list the number, describe on number line the integer between 3 and 9. Di antara 3 dan 9, so we have this one. Integer greater than negative 3. So it is lebih besar daripada negative 3. For negative, the smaller the number, dia lagi besar. The greater it is. Okay, tengok dekat sini. Yang ni negative 5. This one is negative 2. So this one lagi besar daripada yang ini. So don't get bored yet. We still have lots of examples. Okay, represent the following interval on the real number line and state the type of the interval. Okay, you have close interval, negative 1 until 4. So close interval, negative 1 until 4, you can draw it like this. You have close bracket, okay? And you also have shaded dot. And then open bracket, 2x greater than 2 less than 5, which means it is open interval. Kalau close interval, dia ada tanda ni. Ada tanda sama dengan equal. So you have C half close, half open. So this one you can call it half close, half open. So 2 until infinity. So it start with 2 until infinity. So just let it be like this, open, kan? And this one also x less than or greater than 0. X less than or equal to 0. Lebih kecil atau sama dengan 0. So kita ada ni lah. So next we're going to see about intersection and union operation. What is intersection? Intersection mean you have this kind of symbol. Ada macam N macam tu kan? Small letter of N. That one is intersection. This was N. This one is union. So give an example. A is half closed, half open. Close start from 1 until 6. So this is 1. This is 1 until 6. 6 is open. And we have B over here. B negative 2 until 4. Negative 2 until 4. This is B, okay? This is B. And this is A. So that is how you're going to draw it. And then we're going to identify where is the union of these two sets. Union means you're going to combine the whole thing of these two sets. Kita gabungkan kedua-dua ni dari sini until yang dekat sini. So you have this whole thing as the union. And how about the intersection? Intersection means yang bertindih, yang bersilang. That one is the intersection. So this is, di sinilah dia intersection dia. Okay. So I hope you're clear about intersection and union. That is just a recall to what you have learned in your mathematics in SPM, during your SPM. It's quite easy. So I guess I can skip this one. You can try it later on. It's quite similar. You just need to apply the intersection. Which one is the intersection? Which one is the union? Okay. It's quite a lot of examples. So I will let you try it on your own. Solve the following using the number line. Okay, you have this one. You just have to this set of number. You just have to draw it in your number line. And then you're going to find where the union and where the intersection. Okay. This is quite easy. I'm not going to explain it everything. Okay, I think that's it for the first subtopic. That is quite long for the first subtopic, which is real numbers. So next, we're going to take a break before we proceed to the second subtopic, which is indices.